The following is the video solution from JSDT Solutions. Question 8 says the graph of y equals f prime of x, so this is the derivative of a cubic function, is equal to mx squared plus nx plus k, is drawn below. The graph passes the points P, Q, and R. And the first question, 8.1, says determine the values of m, n, and k. Okay, so we need to find the equation of this parabola. Let's just look at what we have been given. We have been given a parabola with two x-intercepts and one y-intercept, which is just another point. So we can use the x-intercept form of a parabola, okay, a parabola's equation, which looks like this. And we can just follow what they called these. So they said mx squared plus nx plus k. So we can go ahead and remember that the original form looks like this. Y equals a multiplied by x minus x1 multiplied by x minus x2. Okay, but our a value here is m. So we'll just put that as m. Okay, so this is what we have, and these would be your x-intercepts. We're going to put down the x-intercepts in there. So our x-intercepts are -1/3 and 1. So our equation so far is y equals m times x minus -1/3, which becomes +1/3, and then multiply by x minus 1. And now at this point, we almost have our equation. The only thing missing is m. Okay, so in order to find m, we just need one point that has an x and a y value. And we have a point. We have this point r, 0 and 1. So we can go ahead and substitute 0 and 1 into this equation. So this will go in the place of x, and that is y. So we'll say y, which is 1, is equal to m times 0 plus 1/3 times 0 minus 1. Okay, so over here, that is just 1/3 times -1, which gives you -1/3. So this is -1/3. M is equal to 1. And then if you divide both hand sides by -1/3 or multiply both sides by -3, okay, to get rid of that in the denominator, you see that m is finally equal to -3. Okay, so we still have to make sure that we find n and k as well. So we can go ahead and take this -3 and substitute it into this equation that was almost complete. Okay, so that now becomes -3, and then we can distribute that. So y equals -3 multiplied by distribute. It's x squared minus x plus 1/3x, and then minus 1/3. So this simplifies to y equals -3 times x squared minus 2/3x minus 1/3. Okay, so doesn't even matter that we have 3 in the denominators because these would multiply. And even though it doesn't matter, it is what it is. So the equation is, did they ask for a specific form? Not necessarily. So I'm just going to leave it as y equals -3x squared plus, and when that multiplies, it cancels out that 3 there. So positive 2x, and same thing, positive 1. And so now we can see that the value of m, which we already found, was -3, n is 2, and lastly k is 1. And there we go. Those are the values of m, n, and k. Question 8.2 says, if it is further given that f of x is equal to this, okay, we need to determine the coordinates of the turning point. So how do we find the turning point of a cubic function? To find the turning point, we're really just using the idea that at the turning point, the gradient is equal to 0, because this is where it's neither increasing nor decreasing. So to find the gradient of this function, we derive it. So we say f prime of x is equal to, and let's derive, that will be -3x squared plus 2x plus 1. And then we set the gradient equal to 0. So 0 equals -3x squared plus 2x plus 1. Okay, so you can just choose to take everything over to make it positive. So that's just 3x squared minus 2x minus 1 equals 0. Okay, so now we just need to factorize this, and you can use any method that you are comfortable with. So I'll just go ahead and use the cross method here. Factors of 3x squared, 3 is a prime number, so it's just 3x and x. Factors of 1, it's just 1 and 1. And now we just need to see how this should be put. This needs to be negative, so one of these ones should be negative. So I'll go ahead and give the 1 to the factor that I can see will become bigger when we cross multiply. So that's going to be minus 1 and positive 3. Okay, so let's just test to make sure that it gives us our middle term. So 3 times negative 1 is negative 3x, right? And then x times positive 1 is positive x. And that indeed gives us negative 2x. And that is the middle term. Okay, so our factors are 3x plus 1 and x minus 1. Okay, this is what we have. And now we can just solve for x here. Solving for x here, you'll say 3x and then plus 1 equals 0. Transpose the 1 to get negative 1 and then divide both hand sides by 3. So here x equals negative 1 over 3, or x equals, transpose the negative 1 and you get positive 1. So these are the x values of the turning point. All we have to do is take them and substitute them into the equation to get the y value. Okay, so we're just going to say f of negative 1 over 3 and find out what that would be. And when we substitute, we get 49 over 27. Okay, so that's the first one. And then the second one, let's go ahead and find that. Okay, and the second one is f of 1. So let's substitute that. And when we substitute 1, we get 3. So our turning points are simply just negative 1 over 3 and 49 over 27 and 1 and 3. And those are our turning points. And that is our answer. Moving on to the next question. Question 8.2.2 says, draw the graph of f. Indicate on your graph the coordinates of the turning point and the intercepts with the axes. Okay, so here is an order that you can follow. To draw this graph, you can always keep in mind the things that they specifically ask for, so you don't forget these points. They want to see the turning point and they want to see the intercepts, the x and the y intercept. So to draw this graph, we're first going to look for the shape of the graph, okay, to see what kind of shape it gives. Now, seen from this question where they gave us the graph of f, we can see that the value of a in ax cubed is negative. So our graph looks like this. So it's like a backwards n, just more curved. So that's the first thing we know. Then the second thing we know about our graph, or the second thing we have to find, would be the turning points. We already know the turning points, so we can just put them down. Those are the turning points. Now, it would be helpful for you to know exactly where these are. Negative 1 over 3 is negative 0.3 recurring, right? So 49 over 7, just so we can know where to place that, we're going to just put that on the calculator and see the decimal form of that. Okay, so that is about 1.814. Okay, just keep that in mind. Then the third thing we can look for would be our intercepts. Okay, so that is the y-intercept. And the y-intercept can clearly be seen looking at the constant. Okay, if you substitute x, when you make x equal to 0, this is the only thing that will remain 2. So our y-intercept is where x is equal to 0 and then the y value is 2. And then the x-intercept. Now this one, we're going to need to do some calculation. This is where y is equal to 0. So let's take our function and then make y equal to 0. Okay, so to factorize this, there are different methods, but here I'm going to use the long division method to find this. Okay, so first we'll draw an L. It's like a backwards L, and we're going to put down the coefficient of each term. So the coefficient of x cubed is negative 1. And then the coefficient of x squared is positive 1, which is 1. And then of x is 1, and then the constant is 2. Now, the number that will go here would be whichever number is a factor of this expression. What I mean by that is when you take that number and you substitute it into this, it gives you 0. Now, that number comes from somewhere. It comes from this last term. You're going to look at 2, and you'll find the factors of 2. So the factors of 2 will be 1 and 2, negative 1 and negative 2. So when you substitute these numbers into this equation, it should give you 0. So the number that goes here is really the solution, not really the factor. Now we have substituted 1 into this because it was one of the turning points. It was 1 and 3. We know it gives us 3, not 0. So let's go ahead and try to substitute 2 and let's see what that gives us. And when we substitute 2, it gives us 0. Okay, so that works out. So since f of 2 was equal to 0, then it means that 2 is a solution. So 2 is a solution. But what this would mean is that x minus 2 is one of the factors of this expression, okay, of this cubic function. So what that means is once you find the other ones, once you factorize them, then this is going to be one of the factors. It's this times whatever will be here and times whatever will be here is equal to 0. Okay, so this is a factor. Okay, so we now know the number to put here, and here's the long division method. First, we'll pull down this number here. Okay, it's still -1. And then we'll say -1 multiplied by 2, which gives us -2. And we put that here. And then we say -2. And this is a positive 1. So that's -2 plus 1, which gives you -1. The -1 times 2 again is -2. And again, -2 plus 1 is -1. Then -1 times 2 is -2. And -2 plus 2 is 0, and that's one thing that should happen. You should end off with 0. So what this means is our factors, when we factorize that, is this. We first have the factor x minus 2, and then we have these as factors, which would be, they are the coefficients of our quadratic expression. So they're in the form of x squared plus x plus c. So this is going to be negative x squared minus x minus 1, and then is equal to 0. And we would have to solve for x in this equation. Okay, so that means x minus 2 is equal to 0, or negative x squared minus x minus 1 equals 0. Okay, so here x equals 2, and here if you multiply both hand sides by -1 to get rid of that negative, this is going to be x squared plus x plus 1, which cannot factorize. You can't factorize this because even if you opened up two brackets and you said x times x gives us x squared, you see the factors here would be 1 and 1. There's no way that all of these are positive and then they give you a positive x in the middle, because once you say x times 1, that gives you x, and then x times 1, that also gives you x. That's 2x. So we can't factorize that. You would have to use the quadratic formula, but it's best to check if it actually has any solutions. So you can do that by testing it using the discriminant. So discriminant is equal to b squared minus 4ac, and then we can just test it out. So that's going to be, the b value is 1. 1 squared minus 4 times the a value times the c value of 1. Okay, so 1 minus 4 is -3. There's the problem. Our discriminant is less than 0. You're going to have non-real solutions when your discriminant is negative. Okay, so there's no solution here. Okay, so that's something that you can just do on the calculator. So here we will say there are no solutions. Okay, no solution. And the only x-intercept we have is 2 and 0. Okay, let's go ahead and sketch our graph. So we can start off by drawing our x and y axis. And now, okay, that's our y, that's our x. And we can just focus on putting down the important points, really. Okay, so first start with your turning points. That is going to be about -0.3 and 1.8. So let's just find out where that is here. -0.3, okay, it's the x value, so it's on this side, and then 1.8 will go up, okay. And once you have that down, make sure you write the coordinates of that point, okay. Now, it's important to make sure that you're going to write all the other points relative to this position. So based on how it relates to that, okay. So the next point we'll write is the other turning points 1 and 3. So if we were here, we go 1 and then 3 units up. Okay, so that's roughly here. 1 and 3. And then our other points. Now we have a y-intercept of 0 and 2. And we have an x-intercept of 2 and 0. So 0 and 2 is about here. Okay, so we have that. And you can just say 2. So we know, okay, it's a y-intercept of 2. And then an x-intercept of 2 and 0. So that's going to be about here. It's just past 1. Okay, so here. And now with all those points, you know that the graph looks like this. We already figured out the shape of the graph. So this graph is going to go like that, up, like that, and then down. Okay, I'll just draw those points properly. Okay, so that is what our graph will look like. And this is the graph of F. Okay, so that is it for question 8.2.2. And moving on to the next question. Question 8.3 says, points E and W are two variable points on F prime and are on the same horizontal line. And we have H is a tangent to F prime at E, and then G is a tangent to F prime at W, and H and G intersect at D, which is A and B. Okay, so we have that graph. We have two tangents, however they are drawn, to that graph. And then those two tangents intersect at a point called D. And we need to find the value of A. Okay, so let's get the diagram down so we can draw this. So here's our diagram, and I'm just going to leave some space since those tangents must intersect. This is what is going on. We have this tangent, H. And the tangent H intersects F prime at E at two variable points. So we don't really know what exactly their X and Y values are. But we have a tangent intersecting like that. And that one is H, right? And let's just say this is where it intersects. So we're going to call this point over here, that point E where it intersects. We can just go ahead and call it, because we already have A and B here, let's just call it C and D. Okay, two random points like that, two variable points. But the thing is that these points that they intersect at, these tangents, they lie on the same horizontal line. So then we have another tangent intersecting again at another variable point. Okay, so this is the graph of G. Again, it's going to intersect here and they're on the same horizontal line. Okay, so it intersects here and we can just call that point, the name of that point is W. Okay, so we just put in these down so we can see what's going on. We can call the coordinates E and F. Okay, so this is what's happening. And then these two tangents intersect at this point D. And they just want us to tell them what exactly is A, the X coordinate of this point of intersection. So here's the idea behind this. We have tangents, okay, drawn from the same point to a curve. Okay, and they are drawn from the same point and they are on this horizontal line. So that makes these two lines equal. This line is equal to this line and we have an isosceles triangle. Now to find out what exactly that is, do you see that if this is an isosceles triangle, then A, the X value of that point of intersection, A would be the midpoint of these two lines, since this line must be equal to this line. So we just have to find the midpoint. Okay, how do we find the midpoint? So here's how we can think about this. We can actually make an example of two other points that also lie on the same horizontal line on this graph. And that will be the x-axis. You see this? The coordinates P and Q, those x-intercepts, they lie on the same horizontal line and they're also on the graph of F prime. If you were trying to find that middle as well, that A value, do you notice that it's going to be exactly the same thing? So if you ever draw a horizontal line at any point on this graph, you will notice that the middle of those 2 points would be that X value of the parabola's turning point. Okay, so all we have to find is the X value of the parabola's turning point. You can use the graph that we already have, or you could just use these X values. We can just use the X-intercepts to find this. So we'll find the midpoint of the X-intercepts. So A would be found by saying, we only need the X values because the Y values are still 0. So that's just going to be -1/3 plus 1/2. That's how we find the midpoint. And then we know that's going to be 2/3. And then it's multiplied by a half. 2 and 2 would cancel. And now we can see that A is simply equal to 1/3. And that is our answer. Question 8.3.2 says, determine the value or values of B for which H and G will no longer be tangents to F prime. Okay, let's get this graph down so we can look at this. So currently these two graphs, H and G, they're tangents, right, to this parabola. But we need to ensure that there are no more tangents by telling them what the value of b should be for this to happen. Now, b is a y value, okay? It's a y value of this point d, meaning depending on how we move this, okay, whether we're going to shift it up or down, that shift in that point is going to affect the graphs. These graphs should still intersect at that point. So let's look at it. Let us consider an upshift, okay? Okay, so if we moved it up, and honestly, the best way to explain this would be with an animation. I just want to show you guys something here with this. You see, we need to ensure that everything that they stated about these 2 points are still true. So we could think about directly picking these graphs up and actually shifting them up. But please remember this, that they said points E and W are 2 variable points on f prime. So they still have to be on the graph of f prime and on the same horizontal line. If I shifted both points just up like that, then of course they lie on the same horizontal line. Okay, wherever E was, it will be here and W would be here. They would still be on the same horizontal line, but they will not be on the graph anymore. So we need to manipulate it in such a way that they stay on the graph and they are still in the same horizontal line. And here is an animation that I've created to show you guys this. Since we're trying to manipulate the value of b is the y value of this coordinate of d. If you're trying to manipulate a y value, if you change its value, you're either going to move that point up or down because it's a y value. So now that we understand that we need to either move that point up or down, okay, and not saying the graph, the points, because they said specifically b, and that is a coordinate, okay, that's the y coordinate of that point of d. Okay, so let's think about that. If we move that point up, so that means we're just taking the value of b and we are increasing it to higher than whatever it was currently. These tangents, look at what happens to them. D is still the common point of intersection. You see what it did to the graphs? Well, doing that doesn't really solve the problem because they're still tangents. And because they're still tangents to this graph, it's not going to work. We need them to not be tangents anymore. Okay, let's try moving it higher than when it currently is right now. See, it still doesn't solve the problem because H and G are still tangents to the graph of f. Now, because of the way the parabola works, and because of the way it is curved, it's still not going to solve the problem. If you keep moving that point up, if you keep manipulating b to be a higher value than what it was. So, how about we try moving this parabola down? But let's just reset it and put it back to what it originally looked like. So this is what it looked like. Now we're going to take that point, or we're really manipulating the value of b, and we're going to manipulate the value of b to make it a lower value than what it currently is right now. Let's look at what happens to the tangents. You see, now the tangents, they are still tangents to this graph. They're still intersecting the parabola at one point. So that doesn't solve the problem, but we're getting somewhere. Let's move it even lower. So when we move it even lower, you see that it's getting closer to the turning points. We're just trying to make these tangents not tangents, meaning they must not touch that parabola once. Okay, so let's see. How about we take that point and we move it right to the turning point, okay? Let's move it right to the turning point of the parabola. And look at what happens when we do that. Let's just monitor the graph of H first. Let's see what happens. If you move that point of D and you make the B value to be exactly the Y value of your turning point of that parabola, look at what's going to happen to that tangent of H. It's still a tangent to this graph, but now it is a flat horizontal line, which makes sense because at the turning point, the gradient is 0. So it makes sense that it's making a flat horizontal line because horizontal lines have a gradient of 0. That's why they're flat. Okay, and the graph of G does the exact same thing. The gradient is 0. This is a flat ground. it's still a tangent when we move it down until the turning points. The thing about this is they look different now. They're both in the same position, the exact same place, but there's still a tangent to the graph of f. They're tangents at the turning point now. So let's take that point D, right? We're manipulating the value of B. Let's make B a lower value than what that Y value of the turning point is. Let's see what happens when we do that. Okay, so if we move that down, let's see what's going to happen. And let's just monitor first of all the graph of G. So remember, they are going to move at the same time, but I'm just moving it one by one so that you can see what's happening. If we move the graph of G, do you see now, is this a tangent now to this graph? No, it's not a tangent anymore. And because it's not a tangent because it's intersecting the parabola at two places and not one place anymore. So it's not a tangent anymore, it's now a secant. Okay, let's take the graph of H and let's do the same thing because they're actually supposed to move at the same time. So there we go. The graph of H is also now a secant. It's intersecting the parabola at two places. So if we take the value of B and we make it lower than whatever the Y value of the turning point is, then it's not going to be a tangent anymore. They're going to be secants. We have to find out what exactly that point is. If we can find out what that point is, then we'll be able to find out what exactly we need to make the value of B to become less than. So looking at that value of B, what can we do? Well, first of all, since we're trying to find out what exactly that's going to be, we can take the actual formula for the parabola and we can substitute 1 over 3 since it is the x value of the turning point. And to find the y value of the turning point, we can substitute that into the equation. And when we do that, we get 4 over 3. So now we know what's there. That's 4 over 3. That is the y value of the turning point. So if we can just make that b value to be anything lower than 4 over 3, then it's going to make these tangents not to be tangents anymore, but rather to be secants. So b just needs to be less than 4 over 3. Okay, and that's how we solve that problem.